We love stories about human triumph, but this one's different. It's a story about a battle between our incredible ambition as people and the cold, hard, unforgiving laws of physics.
So let's go back. The date is January 28th, 1986. Picture it. The Space Shuttle Challenger is on the launch pad. It's carrying 7 astronauts and really the dreams of an entire nation. The air is absolutely electric, just buzzing with anticipation. But there was something else in the air. It was dangerously, historically cold.
And then left off. For exactly 73 seconds, everything looked perfect. It was a flawless ascent, just climbing higher and higher into that crisp blue sky. For those 73 seconds, you're thinking, here we go again, another massive win for the space program.
And then, just like that, it was gone. In a single, horrifying instant, the shuttle was just consumed by a fireball. The mission, the crew, even that sense of invincibility we all had, it all just vanished against the sky. Okay, so what happened? The official report, well, it points to a simple mechanical failure, a faulty O-ring. But honestly, that's just the surface of the story. If we really want to understand what went wrong, we've got to peel back the layers and find out what was really going on.
See, the true villain here, the real antagonist in this whole story, it wasn't some piece of machinery. No, it was the cold itself. This is the story of how a basic, fundamental principle of science, of how things work, led to an absolute national tragedy.
So, to get to the bottom of this, we've got to talk a little bit about the science, specifically how the cold basically wages war on one very specific, very important material, rubber.
Okay, so what is an O-ring? Deep inside those massive, solid rocket boosters, you've got these little things. Their job sounds simple, but it is absolutely critical. They're basically rubber gaskets, and their entire purpose is to create a perfect seal in the joints of the rocket. Think about it. They have to keep this controlled explosion of super hot gas, we're talking over 5 million pounds of thrust, contained inside the rocket. No leaks, period.
Now, this rubber, it kind of has a Jekyll and Hyde personality. When it's warm, it's great. It's flexible, it's bouncy, it's resilient. It can squeeze and expand in a split second to form that perfect seal. But when it gets freezing cold, that same rubber completely changes. It loses all that elasticity. It gets stiff, brittle. It basically turns into something more like a hard plastic.
And the consequence of that change? It's staggering. Look at this. On a warm day, that O-ring does its job almost perfectly, no problem. But on that freezing cold launch day, its ability to create that seal just falls off a cliff. It couldn't expand fast enough to plug the gap. It was literally a time bomb just waiting to go off. But here's the thing. This wasn't some unknown variable. This danger wasn't a surprise. And this is maybe the most chilling part of the whole story. The disaster was predicted. And not just predicted, but predicted with scary accuracy the night before the launch. The very engineers who designed these rocket boosters, they were practically pleading with NASA officials. They showed them charts, they showed them data from past flights. All of it pointed to one clear, undeniable thing. Cold temperatures meant O-ring damage. They argued, they begged for the launch to be delayed, but NASA, they were under immense pressure to launch. And so the engineers' concerns rooted in basic physics, they were just overruled. Listen to this. One of the engineers, Roger Boisjoly, his testimony from the night before is just haunting. It's a direct prediction of what was about to happen. He said, and I'm quoting here, "The temperature of the O-ring is a very critical factor. I am concerned about the ability of the seal to hold at this cold temperature." He knew the risk. Why? Because he understood the science. So the warnings were ignored. The countdown continued. Let's break down exactly what happened in those final 73 seconds. It was a catastrophic chain reaction, and it was all set in motion by one thing: the cold. Okay, so ignition. Right at that moment, the now stiff O-ring fails to seal the gap. We see a puff of black smoke. That's the first fatal clue. Then something almost miraculous happens. A temporary plug made of fuel residue actually seals the hole. For about a minute, the problem is completely hidden. But then the shuttle hits some strong wind shear. The whole rocket structure flexes, that temporary plug gets knocked loose, and a jet of flame, like a blowtorch, erupts from the joint. And it's aimed right at the external fuel tank. From that moment on, the end was inevitable. So, in the aftermath of this tragedy, the investigation had a huge challenge. They had to prove this pretty complex failure of material science to a world that was just grieving. The big question was, how do you make everyone see and understand the real invisible culprit here? The cold. I mean, think about it. How do you actually show people that a simple drop in temperature was the root cause of something so complex, so devastating? Well, it took a moment of brilliant and incredibly simple science. This is one of the most famous moments in science communication, really. During a televised hearing, the brilliant physicist Richard Feynman, he takes a sample of the O-ring material, puts it in a C-clamp, and just dunks it into a glass of ice water right there on the table. He pulls it out, takes off the clamp, and shows everyone how it had lost all its bounce. It didn't spring back to its original shape. Just like that, in one elegant, undeniable demonstration, he made the invisible flaw visible for the entire world to see. At the end of the day, the legacy of the Challenger is a really painful but absolutely vital lesson. It's a stark reminder that no matter how big our ambitions are, no matter how tight our schedules or how immense the pressure to succeed is, some things just aren't negotiable. You just can't ignore the laws of physics.